It's my pleasure to be here. Some of you might not know this. I used to work here at Target almost a decade ago. And it's wonderful, it's really wonderful and very emotional for me to come here. So today, this topic is very exciting for me, something I started working on last year, and it's working wonderfully well. So I'm here to really share with you my excitement at how well it's working for hundreds of our customers. I'll start by saying that language models have taken the world by storm over the last few years. That's an understatement. But you know, we're all running around, scrambling around, building agents. And I want to share with you that I've spent the last 6 months meeting with hundreds of our customers, and I'm listening to all the leaders at these large enterprises. And there's a consistent commentary from all of them that, you know, Ashwin, all these vendors, all my teams are building all of these agents that are very attractive in these demos, but are not quite working in production. They're not able to withstand enterprise complexity. So that's what I want to talk to you about today. Enterprise complexity, those of you who work at large companies, of course, folks at Target, but I know other folks also are here from large companies. They're really, really complex. There is so much detail there that language models are not going to be enough. This is a thesis I arrived upon last year after thinking about it and after listening to all of our customers. Language AI is only one type of AI. Today I want to share with you there is another type of AI. It's the AI I think many of us old-timers are probably more familiar with. It's the AI of mathematics and structure. It's the AI of domain knowledge. Those of us who work in specific domains like supply chain and pricing or maybe finance, we have so much understanding of the space. We construct these models in our head. We construct data structures, we construct algorithms, math models. That's a different type of AI, and it's very complementary. So this term, I know it's very hard to pronounce, neurosymbolic, I wish it was easier. Neuro refers to, by that I refer to the language models AI, which is incredibly powerful. I did not expect it would be so amazing. I love it. The symbolic AI, less familiar, something from the past, from decades ago. We're all trying to bring it back. And if you combine these two things, some magical things happen. And my goal now over the next 15 minutes is to talk to you not as a professor, but as one of your colleagues, and I want to explain to you this difficult to pronounce thing, neurosymbolic, in very simple terms. So let's get started. So you all heard all this jargon, you know, an agent. The picture on the left is what I call an agent that's not quite working well. It's depending far too much on LLMs. The LLM is extremely important. We wouldn't even be talking about agents. It's super powerful. But there's a lot more to it. You know all about this stuff. Context, tools, control, evals. I won't go over it. But they're equally important. And now we call it harness. So the picture on the right is a more healthy picture where the hard work is done, not just by the language model, but by the harness, those 4 things underneath the LLM. And that's a healthy enterprise foundation. And my thesis, to put it in simple terms, is that the top one, the LLM, is the neural AI. Why do we call it neural? Because these are very deep neural networks, powerful at statistical pattern recognition. And the other 4, the harness engineering, if you want to do it right in a complex enterprise setting, my view is that you have to invest in something deeper, more rigorous, and I call it symbolic AI. So with that, I'll make a slight detour. Now, apologies, I said I won't talk like a professor. This may seem like a professor, but I promise you I'll come back to the realities of the enterprise in a few minutes. So this picture, the left-hand side of the picture is like the language AI. Let's call it neural AI. The right-hand side picture I'll come to is symbolic AI. We know about all the amazing things with language models. Incredible powers of sensing and perceiving. The powers of statistical pattern recognition have been way beyond what I expected. And even if you ask the gurus of neural networks and language models, even they will tell you they did not expect how amazingly powerful it would get. So here we are, we've got scaling, speed, adaptability, all these things. But remember, the statistical pattern recognition, although it's a strength, it can also be a weakness. Why do I say that? It is a strength because it's the science of approximations. That's actually a strength, but that can be a weakness, and it manifests itself in what you see as hallucinations. You should not think of hallucinations as a bad thing. This is just how it is. It's statistical, it's the science of approximations. The good comes with the bad. But that's why you have this complementary AI on the right-hand side. It's exactly the opposite. What's the strength of one is the weakness of another, and vice versa. But I promise you, if you combine them, what you'll get will be better than the sum of the parts. So what is this? This you'll be familiar with. This is domain knowledge. You have rules, you have constraints. 2 plus 2 is 4. It cannot be 4.1 or 3.9. It's exact. It's an exact science. This is your discrete world. This has the powers of reasoning, logic. Think about building an enterprise knowledge graph. You take your entire company and structure it precisely. You respect all the constraints, all the rules of the enterprise, also respect all the decision rights you have in a company. It's very complex. Think about how much complexity there are in organizations with people, processes, technology. You got to capture all of that in detail in a precise manner, and that's what you do with symbolic AI. But symbolic AI is not just knowledge graphs and rules and constraints. It's also the mathematical models, algorithms. What are we talking about? You're all familiar with this. Forecasting models, optimization engines, causal algorithms, all of the good old stuff we've been working on for decades. Remember, operation science is 100 years old. Don't throw it away. This is your foundation. These two AIs are equally important. The best part of symbolic AI, everything is auditable because it's based on exactness. It's based on knowledge graphs, logic, mathematics. You can trace it precisely. So now I'll tell you about sort of the complementarity of these two things. The left is the AI of language, like I said. The right is the AI of mathematics and structure. The left is the AI of approximations. The right is the AI of exactness. The left is the AI of intuition, and the right is the AI of rigor and reasoning. Those of you who have read Dan Kahneman's book, Slow Thinking, Fast Thinking, you know, we humans are also like this. Sometimes we're thinking fast, intuitively, we look at something, we get a reaction, and often we are right. That's the intuitive type of intelligence we have. That's analogous to neural AI. But we are also slow thinkers. We go back, we think about it, we structure it. Sometimes you create a spreadsheet, organize your thoughts. That's the AI of reasoning and logic and slow thinking. I'm running short on time, but I'm very tempted to give you a sports analogy. I'll do it really fast. So if there's two ways to learn tennis. One way is how most of us learned it. Your coach will teach you tennis in a very controlled, rigorous, exact way. They'll tell you, you need to bend your knee this way, you got to hold your racket this way, and if this happens, this is how you play. That is the symbolic AI way. It's exact, do it, you don't question it, there are rules. There is another way to learn tennis. You just keep hitting the ball, and you just see what happens. Certain patterns in which you play, you realize you're winning, and certain patterns you're losing. And that analogy is interesting because if you listen to Roger Federer's interviews, he learned tennis the symbolic AI way with coaches and structure. But as he encountered Nadal, he realized he has to adapt, he has to change. He has to figure out the patterns of success, and that is the neural AI way. This is a very vague analogy, but I hope it'll help you understand a concept at some level. All right. Now enough of academia. Let me come to the practical realities. So I told you the foundation of symbolic AI, so we don't have to talk about neural AI. Great companies, incredible companies like Anthropic and OpenAI and Google and Meta, they're building these really, really powerful things for us. And we are lucky, we have it for free. I should be careful if I say free. But you know what I mean. You kind of get it, we don't build it. We are not as smart as them. What we do is we use it, and our job is to build a symbolic AI to complement it. We should put all our energies in that. So the foundation of symbolic AI, before I come to the decision models, you got to build the enterprise knowledge graph. There are 4 layers. This is how I build it. The first level is the basic level. It's your value chain graph. What are we talking about? All your products, all your customers, your locations, your plans, and all the situations that happen outside your company. This is like the digital twin of your enterprise. Now, where it gets interesting is when you get to the second level. That's the decision context graph. Imagine if you captured all the decisions of your enterprise. Strategic, CFO, CEO level decisions. Tactical decisions, like what should be our assortment next summer? What should be your network? And also decisions at the lowest levels, operational decisions. How do I move my inventory? How do I do a markdown? Capture all of it. Decisions made by humans, made by agents, all of it. Why am I doing this? Because I'm going to also capture the context around the decisions and connect those decisions to outcomes. What kind of context? Who made the decision? When was it made? Why was it made? What were your choices in the decision making? What were the facts you used? What were the assumptions? All of that detail. Then, when you have that and you connect it to the outcomes, you can find patterns of good and bad decisions. This gets me to the third level, where you take all of those decisions and those outcomes and the good patterns, the learning algorithm, you build a learning algorithm that'll figure out the good and bad patterns, and the good patterns of decisions, all of these decisions, they will get codified in the form of institutional policies and rules. Why do we need this? Because this is the blueprint by which you want to run your organization. This is how you're going to get better and better and better. Okay? And the last layer is sort of all of your computational algorithms. Think about inventory management algorithms, all of your operations research, pricing algorithms, marketing. Big companies tend to be siloed. You make these decisions separately. What I like to build is a connected computational engine where inventory depends on pricing algorithm and marketing and vice versa. When you connect them all together, you can build these push and pull systems so that when a celebrity makes a tweet that I ran in these running shoes, you want your system to instantly respond and pull in some of this inventory of those type of shoes, hold back inventory of other shoes that get cannibalized. Your forecast has to update instantly. Your marketing may have to change instantly. And your inventory order needs to update. This all needs to happen quickly. Now let me show you what kind of data should go inside this EKG. Let's start with the left. EKG, Enterprise Knowledge Graph. Traditionally, we've been building enterprise knowledge graphs for a long time. Traditionally, you only worked on things inside the company, the private enterprise data. But now, we can build these swarms of agents which will go outside the company. It'll pull together your suppliers, your customers, your manufacturers, all relevant for you. You build a so-called world model, a market knowledge graph. This is going to be common across all enterprises. Very powerful, my EKG is now super enriched, inside and outside, private and public. Traditionally, the EKG was structured data, nicely structured tables and spreadsheet. Now, you can pull together exciting, unstructured data. My celebrity tweet example is an example of that. Social media, unstructured data. Let's talk about valuable information in email, Slack channels, competitor information, text and images. The signal to noise ratio is very poor, but that's the power of agents. And thanks to companies like OpenAI and Anthropic, the power of LLMs is to extract the signal out of that noise, and then you structure it. This is how the neural AI is helping your symbolic AI become vastly superior. And the best part is the one on the right, where traditionally the EKG was very stable, static graphs. Now, the EKG, you can pull together real-time streaming in. And so your EKG is now a living, breathing, dynamic, adapting EKG. So, this picture brings it all together. At the bottom here is my foundation of this next-gen EKG. All the things I talked about, the 4 layers, all of this data. So imagine you built all this wonderful, structured, symbolic AI. Now, let's rise up to the top, and let's start to ask all these important questions. Thousands of questions, thousands of problems you want to solve. I'm not just talking about an inventory algorithm or a pricing. I'm talking about big problems in the company. Exec level problems. How do I improve my market share? I'm talking to a lot of our customers who are saying, can I build agents for these complex problems? Improve my market share. Do a post-game analysis on my annual operating plan. The CFO is going to say that. Annual operating plans are not working. By post-game analysis, I mean do a causal inference on it and figure out root causes and fix it and make a better annual operating plan. All kinds of risks and opportunities. The world has become way too complex. Forecasting algorithms. I used to work on demand forecasting here at Target. I think now we can do 1,000 times better on demand forecasting with all the power of LLMs that have come in. Talk about doing industry simulators with all kinds of uncertain variables, large-scale simulators, doing complex integrated optimization, all of these problems. You know, as a technical person, it hurt me last year that I cannot do all this math and programming anymore. These LLMs are far too powerful for me, than me. I got depressed. But today I'm so excited because I am now using all these years of skills to describe these problems. You don't try to solve them. You describe them with precision. You describe them in terms of these entities of the knowledge graph. And I can guarantee you, languages are going to appear not to code and solve problems. Languages will appear to describe problems. So when you describe these problems, these powerful code gen tools like Codex and Cursor and Claude Code, they just become super powerful. So if you're using all these tools and you're not getting the results you want, you think the prompting is poor. No, you need to leverage the power of structured information underneath them. When you do that, these coding agents just become incredibly powerful. So while in the previous slide, I talked about how neural AI is helping build a better symbolic AI with richer knowledge graphs. Here it's the opposite. Here, this bottom, the base of symbolic AI, is helping your neural AI in the form of this Claude Code and Codex tools to become super powerful. I love this synergy. They're really helping each other. And this type of synergy is why the results are greater than the sum of the parts. So now let me just wrap my talk by just telling you how all this neurosymbolic AI is coming together. So people ask me, Ashwin, what are some of the greatest use cases of neurosymbolic AI? There are thousands of amazing use cases I'm building for hundreds of our customers, but these 3 is where I think there's like the biggest game changer. I told you about unstructured to structured already. And post-game analysis, all kinds of inventory, forecasting, annual operating plan, all kinds of post-game analysis. And data integration. It used to be frustrating for me to go to a customer and say, you know, it's going to take me 1 year to take all of your data and build an EKG. That's just too much time today. Now I can do it in days, maybe a couple weeks. Absolute game changer. Thank you for listening to me.